Guys, I hope you are fine. Guys, we do this question and I read the question. Find the integral. So guys, we have an indefinite integral right here, which we want to solve. And so guys, I start off solving the equation. So guys, as you can see, this question, indeed guys, we had done this as a partial fraction. That is, we had looked for the partial fraction of x raised to 4 all over x squared plus 1, all that into bracket squared. And this is what we found, guys, as our solution. So guys, we had this solution as in the former video where we did partial fraction. Guys, please check on my video on partial fraction of this equation. That is x raised to 4 all over x squared plus 1, all that into bracket squared. So this is solution, guys, we found. And now, guys, we want to integrate. So beginning with the first term, guys, this is what we are going to find. For the integral of dx, we get x. For the integral of 2 all over x squared plus 1, this one comes to 2 tan inverse x. Guys, remember that. That is, guys, from the tables, integral of 1 all over x squared plus 1. This one gives us tan inverse x. And so, guys, this is what we find. Then we can put our 2 there. From there, guys, we come now to this other term, whereby we have the integral of dx all over x squared plus 1, you put into bracket squared. Guys, we can now we can say let x be equals to tan u. So guys, we are going to turn this one into tan u, whereby we say let x be equals to tan u. And so therefore dx is equals to sec squared u du. That is, the differentiation of tan u is sec squared u. And then we can put the du this side. From there, guys, we continue. We can now replace for dx. We can also replace for x squared. So when we do that, guys, this is what we are going to have. We are going to have x squared as tan squared u plus 1, all this squared, and then for dx we replace with sec squared u du. Guys, from there we have this and that. We can now actually cancel this sec squared u, and also we cancel this 2. Remember that this one is the same as sec raised to 4 u. And now we have 2 sec raised to 2u. Guys, we can cancel 2 here. And we can also cancel 2 here. We are left with sec squared u. So this one gives us 1 all over sec squared u, which is the same as cos squared u. That is integral of cos squared u now du. Guys, from there we can write this one in terms of trigonometric identity. Guys, this is what we have for cos. Cos 2x usually gives us 2 cos squared x minus 1. And so, guys, we can bring this one this side so that we are left with cos 2x plus 1 on one side, and then cos x squared on this side. Then we can divide by 2. Divide by 2 here. Here we have now 1 all over 2. And this is what now we have. Guys, when we come now and integrate that term and this term, because already, guys, we've been able to replace that. Remember, now we are now not dealing with x, but we are dealing with u. And so therefore, guys, this is what we have. This is what we are supposed now to integrate. So, guys, integrating that, we shall have This is going to give us a quarter sine 2u, and this is going to give us a half u as our integration solution, and this is what we have. Guys, from there we can now come and replace for sine 2u and u. In replacing that, this is what we have, guys. We have this equation. We want to replace for sine 2u. Sine 2u is written as 2 sine u cos u. Remember that this is sine 2u. But now, guys, we have also this. This one is a trigonometric identity which gives us 1. And guys, we have put it there so that we can turn these terms into tan. All these terms, if we divide here by cos squared, we divide here by cos squared. Every of these terms we divide by cos squared. So guys, we shall have 2 tan u all over 1 plus tan squared u. So that, guys, now we are going to replace for tan u. Remember we said that tan u is equals to x. So we shall have 2x all over 1 plus x squared. This is what now, guys, we are going to have. Here we have already, guys, we had this solution at first. Checking on our first solution, guys, we had it here. These are our solution here. We had that and we had that. So guys, we are now dealing with this. And already, guys, we have found now the solution in terms of u, which is this. And now, guys, we now come and replace for 2u and u. Replacing that, I have u is actually here. I have, this is u. Because as you can see, tan inverse x is equals to u. So this was I have u. So guys, we now put tan inverse x. Coming to this other, guys, we have 2 tan u. U we know is supposed to be x as shown here. So we shall have 2x 1 plus x squared, and this is what we have. And then now, guys, we have now plus c. Guys, we can even cancel this one. So we have 1 there, and here we have 2. So guys, we shall have that as our solution. This is going to be plus. I have put like that. I have x 1 plus x squared, all that into bracket, now plus c. So guys, this is our solution. Thank you for listening to me. Bye bye.